this is Tanya. Welcome to Tanya Tina's Maths. I would be teaching CBSE Class 10 Maths, and this is my sister Tina Lopez. I teach 8th Maths. Alright, now let's jump into the video.
Today we are going to be learning Chapter 6 Triangles, Exercise 6.2, 6th question. Okay, so now let's read the question. In figure 6.21, A, B and C are points on OP, OQ and OR respectively, such that AB is parallel to PQ and AC is parallel to PR. Show that BC is parallel to QR. Okay, so this is the question. It's really a good question. Why? Because already we had solved so many sums, am I right? So we are going to be using the same method here as well. Okay, first of all, here now let's look at the important words. So here this one is really important and this one is also important. So these are the informations that is in the triangle. Okay, they had already given the figure in our textbook, so no need to worry. It's just an information that ABC, where is ABC? Yeah, ABC, they are points on OP. Where is OP? OP, OQ and OR. Okay, so this is just an information. Okay, so now the thing what we are supposed to prove is this one, that is BC. Where is BC? So BC is parallel to QR. Okay, we are supposed to prove it. Okay, so here when you just look at the figure, we have a lot of triangles. So here we have one triangle and here we have one triangle, and this is also one triangle, that is POQ, and POR is also in triangle. So we have so many triangles. That is because to confuse us. Okay, but we are supposed to use the same method which we applied in the previous questions. Okay, so first of all, now let us write given things. So before getting into the answer, I would like to ask you a question. So the question is whether are we gonna apply BPT or converse basic proportionality theorem. What are we gonna apply in this question? So in this question, according to me, I am gonna be applying BPT. At first I am gonna be applying BPT, that is basic proportionality theorem. Okay, and what about the second? In second, I am going to be applying another one theorem, that is converse theorem. You guys might be wondering how to use BPT in that particular place. So don't worry, while solving the answer, no, I'll just say the tricks. Okay, so first now let us write given. So now no need to worry about anything, just write given values and what are we supposed to prove. Okay, so that is our job right now. So given. So what is given? So this one is already given in the question, that is AB is parallel to PQ, comma AC is parallel to PR. It is given in the question. Am I right? And now we are supposed to write what are we supposed to prove. So what are we supposed to prove? So what are we supposed to prove? We are supposed to prove that BC is parallel to QR. So now let us write BC is parallel to QR. This one we are supposed to prove. Okay, so to prove something we need proof. Am I right? So let us write proof. I am just writing it little bit fast. Why? Because we had already done these things in the previous questions as well. That's why I'm just doing it little bit fast. Okay, so what are we supposed to prove now? We are supposed to prove BC is parallel to QR. Okay, so where is BC? So whenever they ask us to prove something, we are supposed to check it out in the triangle. According to the triangle, BC is here and QR is here. So we are supposed to prove it is parallel. Okay, so for that, what are we going to do is, we are going to be using the clue words. What are the clue words? That is what is given in the question, right? Those are our clue words right over here. Okay, according to the question, the AB is parallel to PQ and AC is parallel to PR. These are really important. These are gonna take us to a path where we are going to find an answer. Okay, so we are supposed to find an answer by using these two clues. Okay, so listen carefully. Okay, first of all, we have AB is parallel to PQ. Where is AB? So AB is right over here. So let me just mark it. one second. Yeah, AB is right over here and AB is parallel to PQ. So PQ is right over here. Okay, so now it's going to be easy for you guys to solve it, am I right? So where are they lying? AB and PQ. So first of all, now let us write AB is parallel to PQ. Okay, alright, AB is parallel to PQ. So where are they lying? That means in which triangle are they lying? So in triangle POQ, am I right? This triangle. This triangle. Am I right? In this triangle they are lying. So we can just write in triangle POQ. Okay, in triangle POQ. Now we are going to be applying basic proportionality theorem. That is the Thales theorem. Okay, so according to Thales theorem we are supposed to write. So we just took POQ. So now here the important one is the tricky one is they had given the triangle in the ulta wise, upside down. Okay, so normally we used to have triangle like this, am I right? But here it is like this. Okay, so we have the triangle like this. Okay, so pointing to that wise, so like this. Okay, so don't worry. So since we have triangle POQ, since it is like a ulta wise, we are going to be taking the basic proportionality theorem in the ulta wise. Okay, so I know it's hard to understand, I'll just show you guys. So normally we used to take basic proportionality theorem like this, am I right? So for example, this is a triangle ABC and here we used to have parallel line and EF. So we used to take AE by EB is equal to AF by FC. We used to take it like this, am I right? But here it is somewhat different. The triangle is somewhat it is not in the proper shape. Okay, it is ulta wise. That's why we used to get confused how to apply basic proportionality theorem. So we are supposed to apply like OA by AP is equal to OB by BQ. Okay, so OA by AP is equal to OB by BQ. Okay, then only it will be proper. Okay, so OA by AP is equal to OB by BQ. So by using basic proportionality theorem. Okay, by BPT. Okay, so now we got a value, am I right? So this value I am going to be taking it as equation number 1. Okay, so now let us take another triangle. According to the clues only we are just taking the triangles. Don't just think that I am just taking random triangles. Okay, so first I had AB is parallel to PQ and I just found out that AB and PQ are lying in this triangle. That's why I used it, am I right? So next one we have AC is parallel to PR. So AC is parallel to PR, am I right? So now I am going to be finding AC and PR in this figure. So AC is right over here and PR is here, am I right? So AC is here and PR is here. I am not going to mark it with red color. Why? Because already I had marked here, right? So it will be difficult to identify it. Okay, so AC is here and PR is here. Okay, so where are they lying? In which triangle are they lying? So in the triangle POR. Okay, so POR they are lying. Okay, so now let us write first let us write AC is parallel to PR, same step only. Okay, AC is parallel to PR and in which triangle? In triangle POR, and then we are going to be applying basic proportionality theorem. So AC, one second. So now I wrote AC is parallel to PR. Okay, so in which triangle are they lying, AC and PR? Let me show that. So in triangle, where is AC? Yeah, AC and PR, they are lying on triangle POR. So we can just write in triangle POR. Okay, so we can write in triangle POR. So in triangle POR, now we are going to be applying basic proportionality theorem. Okay, So in triangle POR, how can we apply basic proportionality theorem? We are supposed to apply it like this. Am I right? Like this face. So how can we apply? Means OA by AP is equal to OC by CR. Am I right? So like that only we did here as well. So we are going to be doing the same right over here. Okay, that is OA by AP is equal to OC by CR. Okay, so now let us write that. So OA by AP is equal to OC by CR by basic proportionality theorem, that is BPT. Okay, so I am going to be taking this as equation number 2. Because already we had taken equation number 1. Am I right? So I am going to be taking it as equation number 2. Now let us compare equation number 1 as well as 2. From equation number 1 and 2. Okay, so what is there in equation number 1? So when we just compare equation number 1, that is this one, so here OA by AP is equal to OB and by BQ. Okay, now let us see equation number 2. So in equation number 2, no, it is OA by AP is equal to OC by CF. Here something is similar. So here this OA is there, right? OA by AP. So this one in equation number 2, and in equation number 1, here also we have OA by AP. Am I right? Both are similar, exactly similar, no change at all. Since they are similar, no, I mean since they are both are having the same values, no, I am gonna ignore them. Okay, so instead of I am not going to take it. Okay, I am going to write OB by BQ. Okay, I am going to take this OB by BQ because I am going to be ignoring this one. Okay, now let us ignore it. Okay, crisscross. So now let us ignore it, and we are going to be taking this value. Okay, so that's why I wrote from equation number 1 and 2. So from equation number 1 we have OB. So what is it? OB by BQ. Okay, so OB by BQ is equal to OC by CR. So where is it OC by CR? So here in equation number 2 we have OC by CR. I just ignored this one. Okay, so now finally I got a value. Am I right? So since you guys know, when we get a value, we are supposed to compare it with the question, what we are supposed to prove. So is this the value what we are supposed to prove, guys? No, we are not supposed to prove this one. We are supposed to prove something is parallel. Am I right? So now let us check where is OB by BQ and OC by CR. Okay, first let us check that, then only we can get a clue. Okay, according to the triangle, OB is right over here. Am I right? And BQ is right over here. And OC is right over here. And CR is right over here. It is in triangle QOR. Okay, in this triangle. So in this triangle. Am I right? They are lying in this triangle. So since they are lying in this triangle, so here what is the parallel line? So here the BC by BQ is the parallel line. Am I right? Okay, so these both are parallel line. Okay, so is this the one what we are supposed to prove? So we are supposed to check it. Okay, so BC by B is parallel to QR. Am I right? According to this triangle, it is a parallel line. So this is what we are supposed to prove, guys. Am I right? So this is we are supposed to prove, that is BC is parallel to QR. Am I right? So since we got this value, when I just checked these values in a triangle in the figure, I found out that it is having a parallel line, that is BC, which is parallel to QR. So since it is lying on the triangle, I can just say BC is parallel to QR. Am I right? I can just write like this. Why? Because OB by BQ, OC by CR. They are lying on triangle QOR. In triangle QOR, no, we have parallel line, that is BC and QR, which is in which they both are parallel. Am I right? Since they are parallel, no, I can just say BC is parallel to QR. Okay, so just because I got these values only, I was able to find that whether it is parallel or not. Okay, but one more thing I would like to say. So since we wrote BC is parallel to QR, we can't just write randomly like that. So we are supposed to write something near to that. We used to write by BPT, basic proportionality theorem. Likewise here also we are supposed to write something. Am I right? So, but we can't write something. We are supposed to write the actual one. So we are supposed to write by converse. Okay, by converse. Okay, by converse of BPT. Okay, so we are supposed to write by converse of BPT. Why? Because then only we can just write this BC is parallel to QR. Okay, so if you don't write by converse of BPT, then no use of writing this BC is parallel to QR. Am I right? So we are supposed to write this, that is converse of BPT. Then only our answer is correct. Okay, so hence since we wrote by converse of BPT, we can just write hence proved. Okay. So after writing by converse of PPT only, we are supposed to write hence proved. Okay, otherwise please guys don't write it. Okay, otherwise you won't get a mark if you don't write by converse of BPT. So how can we identify by converse of BPT? How means, so here this is basic proportionality theorem, am I right? So this is what we learned in basic proportionality theorem. But according to the question, we want to prove something is parallel. Am I right? So since if we want to prove something is parallel, then we are supposed to write that values which we want to prove it is parallel, and we are supposed to write by converse of BPT. So if we write this converse of BPT only, then our answer is valid. Otherwise, our answer is not valid. Okay. So this was the question number 6. So finally we solved it. This was similar to the previous sums, so it was easy for us.
Thank you guys for watching this video. Please like this video, share it to your friends and subscribe to our YouTube channel. If you have any doubt, you can comment me in the comment section. Catch you in the next video. Bye.